All right, friends, it's time to hit the easy button. Difference of squares is, well, it's really easy to apply, especially if you know to use it. But here's the formula for it. It's a factoring technique that you can use on binomials. All right, this one only has two terms, and it will factor it into two. It factors it into two binomials, really. Depending on the circumstance, it might be linear, it might not be. Anyway, so what it tells you is that when you have two perfect squares, or something to the second power and something to the second power, and when you are subtracting them, you can rewrite it as, I guess, the square root of the first thing and the square root of the second thing, where one's minus and one's plus, and you can write it in factored form like that. So it's really easy to apply. So I'm going to show you for this x squared minus 9. If we wanted to factor that, all right, you have to think of like what thing or what number times itself will give you x squared. Well, that's just going to be x and x. And then what times itself will give you 9? Well, that's going to be 3. 3. And then one will be plus, one will be minus. It doesn't matter which one you put where. Okay? So the x was like our a, and the b was like our 3. Okay? So if you were to multiply this out, x times x would give you x squared. X times negative 3 would give you negative 3x. And then positive 3 times x would give you positive 3x. And then 3 times negative 3 would give you the negative 9. But then these two will just cancel with each other because one's positive, one's negative. So that's why this works. Okay? So it's like you have to think of the square root of these pieces is what you're doing. So for x squared minus 36, okay, x and an x, and then square root of 36 is a 6. All right, and one's plus, one's minus. So it's really easy to apply, but knowing to look out for it, that's the trick. Right? So what number times itself, or what times itself will give you 49? Be a 7. And then what times itself will give you 4x squared? Well, 2 times 2 gives you the 4, and then x times the x will give you the x squared. Hopefully you see how this works out. 2x times 2x gives you the 4x squared. 7 times 7 gives you the 49. All right? And because it's a difference, because it's subtraction, that's what makes it difference of squares. Okay, 49 is a perfect square, and so is 4x squared. Like, if you wanted to be all weird about it, you could rewrite this. You could rewrite it as 2x squared, 2x squared, and 7 squared. If you wanted to be weird, that's how you can think of this. Oh yeah, one's plus, one's minus. Okay. Oh, can't do anything about this. 32 is not a perfect square. 50 is not a perfect square. I guess we'll just end the video. Wait a second. You can factor out a GCF. They have 2 will go into both of them. So I'm going to divide them by 2, and that's going to become a 16x squared, and the 50 is going to become a 25. All right, now this part is going to factor using difference of squares. All right, what times itself will give you 16x squared? Or what's the square root of this? Well, that's 4x. And then, of course, 5 times 5 is the 25. One's plus, one's minus. Not so bad. Not so bad at all. So you got to remember, check for that GCF. You always got to keep that in your back pocket. It does make your life easier. Now, 64 and 121, they don't have a greatest common factor. But it will factor using difference of squares. So the square root of this piece, square root of 64 is 8. and then x times x is x squared. And then the square root of 121 is 11. One's plus, one's minus. And that's it. I'll show you some more in the next video.